I want to take a look at this problem right here. And what I want you to do is draw two graphs. Imagine this motion. Here's how it is. There's a ball at the top of a ramp. It's moving to the right. Positive velocity or negative? Positive. Okay, it's moving at a steady speed, and you know that. And then it goes down the ramp. What's going to happen to the speed as it goes down the ramp? Increase. Then when it hits here, what's going to happen to the speed? It's going to be constant. So it's like moving at a constant speed, and then it speeds up, and then it's going at a higher speed when it gets to the bottom of the ramp. I want you to draw two graphs. I want you to draw a graph of the velocity versus time, and directly below it, draw a graph of acceleration versus time. Here's a hint for you. Velocity is the change in position. If you draw a position graph, how do you determine the velocity from the graph? This is one of the questions on the reading quiz. It's the slope. Acceleration is the change in velocity. If you draw a velocity graph, how do you get the acceleration off it? Think about the analogy to what you've done before. So draw a velocity graph and acceleration graph. I'll call a name out of the box, and we'll do an art critique of your efforts, okay? And you can talk to your neighbors at a normal tone of voice if you'd like. I'm seeing some progress being made here. Laura Knobloch, right here. Can I take a look at your paper? So here's what Laura has drawn. She's got the velocity starts out positive, then she's got a segment where the velocity is increasing, and then you have a segment of time where the velocity is steady again. Perfect. That's exactly what it does. It's steady, steadily increases, and then it's steady again. And this zone right here, something's happening. The velocity is changing. Now, there's three zones I want to consider. Zone number 1, zone number 2, zone number 3. Over here on this graph, I'm going to take it and I'm going to block out the same three zones. Zone number 1, zone number 2, zone number 3. In zone number 1, is the velocity changing? So, is there an acceleration? No. Acceleration is change in velocity. No change in velocity. No acceleration. Excellent. Zone 2, she's drawn a positive acceleration, which is exactly right. Because the velocity is positive and it's getting bigger, that tells me that the acceleration is positive. Oh, how else can I see it? Acceleration is the slope of a velocity graph. Oh, yeah. Positive slope. Positive slope tells me the acceleration is positive and constant. This segment of the graph has a constant slope, okay? Then the ball hits the bottom of the ramp. What happens to the velocity at that time? Becomes constant again. It's steady. And so what happens is this graph drops down and goes here. It's 0 again. So there's kind of a little zone where something happens. There's a little zone where something happens. And then the other segments, there isn't acceleration. Think about that. Think about that.